Hello, we are Memphis Communiversity and we are back with another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we are going to be talking about the derivative of trig functions and inverse trig functions. So this lesson should be pretty easy. It's a continuation of our adventure learning derivatives. In our last video, which was probably far more important, we talked about the power rule for the first time. We took that power in the front, dragged it to the front and subtracted 1. We also talked about the derivative of exponential and logs. For example, e to the x, a to the x, ln x, and log base ax. And for those, we just memorized the derivatives. It's going to be similar today. We're just going to memorize the derivatives of trig functions and inverse trig functions. Then we'll practice some examples. Remember that we're going to be using quite often that the derivative of a sum is just the sum of the derivatives. Same thing with the differences. Same thing with constants. So let's get started. Let's talk about derivatives. So what I'm going to first do is I'm going to list out the derivatives for you, both first the trig ones, then the inverse trig ones. Unfortunately, you do have to memorize them, but just try to memorize them. Try to shove them into your brain whatever way works, because you never want to miss a question just because you forgot a derivative. It's just purely effort. Keep memorizing those derivatives, keep memorizing those derivatives. So let's first talk about the trig derivatives. So these are the trig derivatives. Trig derivatives. There's going to be 6 of them for the 6 main trig functions. The first one is sine. The second one is cosine. Then of course tangent. Don't know why I drew parentheses there. Tangent, tangent. Don't know why I drew parentheses there. So these derivatives, again, I know them from just memorizing them. We're not going to explain them, how to find them, or like why they're true. That'd be teaching calculus right. What we're going to do is we're just going to practice with them. So this derivative is cosine x. This one is minus sine x. And this one is secant squared x. That's not a great secant squared, so let me write this down. And then finally, there's 3 other ones. So there's the derivative of the reciprocal ones. Remember, sine of x is related to cosecant x, 1 over cosecant x. Those are the reciprocal ones. So this is cosecant x. Let me see if I can remember them. Looks like I do, because I use them so often. What has my life come to? This one is secant x tan x. And then finally, last one, let's not forget it, is cotangent x. So hopefully you understand the format of this. Remember that ddx just means take the derivative or the derivative of this thing. So for example, it says the derivative of secant x is secant x tan x. And again, you do need to memorize them. They will be a pain. Just pull out those NX cards and just keep shuffling until you memorize them. Let me give you a few hints on how to memorize them before we list out the inverse trig functions. The main hint that I have deals with the prefix co and negatives. So if you look at these 6 derivatives, if the derivative of the thing you're taking has the prefix co, that means its derivative will be negative. For example, the derivative of cosine has the prefix co, so it's negative. The derivative of cotangent, co, that has a negative in it, or that has a co in it, so its derivative is negative. Derivative of cosecant, co. Not seeing in the Pixar movie, just talking about the co. The derivative of cosecant is a negative because it has a co in it. These don't have a co, unfortunately. Maybe they didn't see the movie. The derivatives sine x, tangent x, and secant x don't have negatives, so these do not have co. They don't have co's and they don't have negatives. If that makes sense. So no co, no negative, co, negative, no co, no negative, and so on. And that's that. Also, they sort of hang out with each other, these derivatives, so notice that they somewhat come in a pair that are fairly related. So sine and cosine are the derivative of each other, except the derivative of co has a negative because it has a prefix. Derivative of tangent and cotangent are also pretty similar. Secant squared and cosecant squared, somewhat related, where of course the co is a negative, so the derivative of cotangent has a negative. Same thing with cosecant and secant. One of them, they're both themselves times a tan or a cotan, so secant x is secant x tan x. Cosecant x is cosecant x cotangent x. Cosecant has a co in it, so that one is negative. But again, no matter what, you have to memorize them. Hopefully you won't miss negatives because of that prefix rule. Let's talk about the inverse trig functions. So remember that inverse trig functions are the same thing as sine to the -1 or arc sine. We're going to use them pretty interchangeably. We will probably use inverse sine more often. And if you like that, these were a pain to memorize, just wait till you see the inverse trig ones. I think they're a little bit worse, but we can do it, friends. We are strong. Let's start memorizing some derivatives. So let's talk about the 6 inverse trig derivatives. So perhaps they're actually not harder to memorize. You just use them a little bit less frequently so that you have a little bit less practice with them, but they do appear on the AP exam. Sometimes the question is straight up, what is the derivative of this thing? Always a lovely question. Just memorizing what we need to know. No thinking involved. I don't like thinking. So what is the derivative of these inverse trig ones? They do involve fractions because they come from what is called the inverse formula, derivative of inverse formula. We're going to cover that quite a bit later, but I feel like it's better just to list them out. Know all the derivatives you need to know right now whenever you might need to know them as you're introducing them. So this one is this. I don't think I'm going to have enough space, but let's see what we got. So this one is the negative of that one. So they all have weird fractions in it. They all have weird denominators with x's. It's kind of hard to remember where the x is, but just keep working at them. Keep trying to memorize them, and so that whenever you need to, you can just recall them. So these are our first 3. Of course, we have another 3. So this is going to be cosecant, inverse cosecant. Notice that as I write them, at least they still satisfy the co-rule. So this one, this is when inverse cosecant will have a negative. It's going to be this guy right here. And then this one doesn't have a negative, inverse secant, because it doesn't have a co in it. So it's going to be 1 over x squared minus 1. And then finally, we have inverse cotangent, which is going to be negative 1 over 1 plus x squared. So these are our 6 inverse trig derivatives. Again, they are a pain to memorize, but really, if you look closely, you're only memorizing 3. You're actually only memorizing sine, inverse tangent, and inverse secant, because these maybe are able to cuddle up or become better friends with their sort of co-function, because notice that one is the exact opposite of the other. So if you have derivative of inverse sine, derivative of inverse cosine, the derivative of inverse cosine is just the negative of the other one. So really, you're only memorizing 3 of them, and the negative rules should help you. One other thing is just look at these derivatives closely. Just be careful of the denominator, of course. So they all involve 1s and x's. Just be wary that inverse tan and inverse cotangent are the only ones with pluses, and they also don't have the square root. So plus, plus, no square root, no square root. These are minus, 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 minus with square roots. And then finally, for these 4, just know the placement. Does it go 1 minus x squared or x squared minus 1? Because unfortunately, those are different. So inverse sine, inverse cosine, 1 minus x squared. Inverse cosecant, inverse secant, x squared minus 1. So these are 6 inverse trig derivatives. Again, they're a pain to know, but slowly as we work through these questions, and it will become easier to memorize and memorize and memorize, and then it will become derivative masters. We'll never forget them again, and we'll sort of evaluate our life on whether this was all worthwhile. But now that we have the derivatives, let's start practicing with the derivatives, and let's reincorporate last video as well, the power rule especially. So let's do a few examples. Then we might do a few harder questions, and then maybe a brain teaser at the end. Who knows what we have in store. So again, let's just start taking derivatives. We're going to take the derivative of x to the 4th minus, let's do 4 tangent x, incorporating a derivative that we're learning, plus 5 e to the x minus 2. So we're going to take this derivative. Pluses or minuses in derivatives are just lovely, because what it does, it allows you to break up this question piece by piece, so we can just take each derivative as we come to it. So let's just get started. This first one is the power rule, the most important rule. You take this number, the exponent, you just drag it to the front, 4x, and then you don't forget to subtract 1. In this case, 4 minus 1, I believe, is 3. So we have 3 here. Then we come to our first new derivative, our first new trig derivative. If you remember, there's a big rule about constants. If you have a constant times a function, when you take the derivative of that, just write down that constant and then write down the derivative. So in this case, we have this minus 4 tangent x. I'm just going to write down the constant, minus 4. And then what's the derivative of tangent x? Well, that one doesn't have a negative because you memorized them and it doesn't have a co. That one is secant squared. Just be careful, this negative does not come from the derivative of tangent, it's just because there's a negative there. So this is secant squared. If this had said sine x, we would write cosine x, of course. If this had said secant x, we would write secant x tan x. Even if this had written, for example, cosine x, we would have just multiplied by the derivative, which is negative sine x. So it's not very much any difficult as you're applying the questions. You just put the correct derivative where it goes. This question right here came from our previous video, but remember that e to the x is the best function in the world. The derivative of e to the x is still e to the x. So what do we do with this 5? Well, we just write plus 5 e to the x. And then what's the derivative of minus 2? At the very, very end, the derivative of any constant, minus 2 plus 2 plus 1/2 plus pi plus e plus square root of 2, all those derivatives are 0 because the derivative of any constant is 0. So this is the final derivative. Nothing too crazy. The hardest part, in my opinion, by far, is just memorizing these dang trig derivatives. So let's practice another one. So we're going to do, let's say 6 to the x square root of x. Change that to a square root of x at the very last moment. And then let's have some more trig derivatives, of course. Let's do a cosecant. Let's put a 3 in the front, just to jazz it up a little bit. And then let's take another function from the previous video. Let's do 4 ln x. And then we'll just have minus 3x at the end. So for the next few questions, and pretty much every single question that we ever produce, don't feel too bad just to pause the video, try it for yourself. I won't watch you, no pressure, no pressure. And then in 3 seconds, unpause the video, let's come together. 1, 2, 3, let's talk about how to take this derivative. So as I mentioned in the previous video, the most important part of my life is probably the power rule, and I want to use the power rule as much as possible. So anything that can be converted to powers, I do that. For example, 6 square root of x, I'm going to write it as 6x to the 1/2, and now I'm going to be ready to take the derivative. Again, we're going to take all these guys separately. So the first one is the power rule. We're going to take the 1/2, drag it to the front, 1/2 times 6, because there's already a constant there. We'll just let them mingle. 6 times 1/2 is 3. That's why there's going to be a 3 here. If you want to do it in 2 steps, you certainly can, but eventually you'll get used to it where you'll do it in 1 step. But this could have been written as 6 times 1/2, where the 1/2 came from the exponent. Then we have 1/2 minus 1, because we have to form a new exponent. Just be careful with fractions. 1/2 minus 1 is 1/2 minus 2/2, which is negative 1/2. Like so. Then we come to our new trig derivative. Let's first write the plus 3 out. What's the derivative of cosecant x? Well, again, you just memorize it, but at least cosecant does have a co, so I know that it has a negative. So I'm going to change this positive to a negative because I like my negatives out here, but you could have written over here. And then what's the derivative of cosecant? It's negative cosecant cotangent. Nothing too crazy. Now we have the derivative of ln of x. That one also isn't too bad. You're going to be taking the derivative of ln of x quite often. We're just going to write minus 4 times 1 over x, or if you're feeling spicy, minus 4 over x. The same thing as minus 4 times 1 over x, the derivative of ln of x. Finally, the last one is pretty easy. What's the derivative of minus 3x? Well, that's the derivative of any number times a constant. It's just that number because it's just the slope. Minus 3 is the answer. If you want, you can rewrite this guy, but I'm not feeling it. This is just how you take derivatives. The hardest one was the power one. Every other one was basically memorization. So let's keep practicing. Let's do 2 more of these, and then let's just do harder questions because I'm getting a little bit bored of this because we're so good at math that this is pretty simple. Let's do some more practice, and then let's go for a harder challenge because sometimes challenges are nice. So let's erase this guy. Let's do 8 over x plus, we need a trig function. Let's actually write 7 to the x first, and then my trig function. Let's do an inverse one this time. Let's do inverse 5 times, let's do sine of a negative 1. So let's take this derivative. Again, when you have something like this, you really want to rewrite it to employ the power rule. It's just so much easier. We're eventually going to use the quotient rule, but I still don't even use the quotient for this because it's just so easy to use the power rule. So what we're going to write is 8x to the negative 1. That's what negative exponent means. Keep in mind that this is not the power rule, this is the a to the x rule, and then this is a new thing. So let's just write the answer down. Power rule time, bring the negative 1, subtract 1, so it's going to be negative 1 times 8, because we took the negative 1, dragged it to the front. Negative 1 times 8 is negative 8. Then we have a new exponent. We just subtract 1 from our old exponent. That's negative 2. Finally, this is not, again, the derivative with power rule because it's a to the x. X is in the exponent as opposed to the base. So this is the a to the x rule. The derivative of a to the x is a to the x times ln a. So in this case, it's 7 to the x times ln 7. And then finally, new derivative, rewrite this constant minus 5. What's the derivative of inverse sine? That's going to be a memorized thing, 1 over the square root of 1 minus x squared. Don't feel bad to put this 5 on the top here if you want to clarify things. You could even write this thing back into a fraction if you want, minus 8 over x squared. But I'm not feeling it. Let's do one more example before we start talking about harder challenges. So the next one, let's do, we haven't done some other inverse sum stuff. Let's do arc secant. So remember, arc is the same thing as inverse secant. Let's put it, let's just keep it like this. Then I'm going to do the rule that people don't usually use very often, the log basis. This is the word log. We can just write the word log this time. Let's change it to 4x with a 2 in the front. So we don't usually use this rule very often, which is why some students don't know it, but you never know when it'll appear. Finally, we're going to add, let's just add x to the 5th. So this question isn't too bad. We are confronted with this thing. This is a memorized, this is the same thing as the derivative of inverse sine. So that's just memorized, just keep practicing your memorization. This one is the one with the square root. It's not 1 minus x squared, it's x squared minus 1. Just little minutia details that you do want to memorize and you do want to keep note of, because if I'm a teacher and you wrote 1 minus x squared, I'd say, ha 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 ha, you wrote the wrong thing, and I'd cut off, because I'm a mean person. Finally, there's an x in the front. So that's just the derivative, just straight up memorization. This is another derivative that you need to memorize. Log base 4 of x, that's 1 over ln of a times x. So in this case, we'll have a 2 on the front or 2 on the top. Then it'll be ln 4 times x. If you want, you can write it as 1 over x times ln 4. And then finally, a little power rule at the end, taking this 5, bring it to the front, 5x to the 4th, subtracting 1. So again, hopefully you'll see that these derivatives aren't too bad. Just when you have a derivative, a special derivative, just write that derivative when the need arises. So let's do something a little bit harder. Let's try to remind ourselves what are tangent lines. Let's practice with tangent line equations, and let's do that sort of action here. So I'm going to erase this, a little bit harder of a question to challenge our minds. Always nice for a nice little challenge. So let's do 3 of these questions, hopefully. So what we're going to do is we're going to have a function. In this case, it's going to be 3 e to the x. Let's do plus 2 sine x. And the question is, find the equation of the tangent line. So find, let me just write out a few words here. Find the equation of the tangent line to the graph of this function, to the graph of f of x at the point x is equal to 0, which is a given. So 2 givens always, the x coordinate and the function. So remember that we are going to be experiencing tangent lines a bunch of times. If this is your first time, it's going to be okay, nothing too crazy. Whenever you have a tangent line, I immediately think that I always need 2 points. What does a line need in order to write its equation? Well, all you need is a point and a slope, so you can write it in point slope form. So that's the 2 things I always want to try to find. I always want to try to find a point, and I want to try to find a slope. And how do you find, what's the significance of the slope? What's the significance of the slope? Well, because we have a tangent line and not just a plain old ordinary line, a tangent line, tangent, that means that the slope is going to be the derivative. So anytime I see the words tangent line, I think I need a point and a slope where the slope is the derivative. So at some point, we're going to take the derivative and plug in 0 for the slope. So we'll do that later. First off, I don't want to do calculus for now. I'm going to deal with just plugging in the point. How do you find the point? You need 2 coordinates. The first coordinate is easy because it's given. The second coordinate will be slightly harder. What we need to do is we need to plug in this number into our function to get the y coordinate. Keep in mind that we'll eventually need some trig stuff. You do need to know unit circle a little bit. So this angle that we're going to be talking about is the angle 0. So it corresponds to the point 1 comma 0. That will help us when we find the sine and the cosine and things like that. So let's get started. Let's plug in the 0 here. E to the 0, any number, finite number to the 0 is just 1. So you'll have 1 times 3. You can just write this out. 3 e to the 0 That would be 3, because it's 3 times 1. Then we have plus 2 sine of 0. So what is sine of 0? Remember, sine is the y coordinate on the unit circle, so it's just going to be 0. So it's going to be 3 plus 0. Nothing too crazy. So what's our point? Looks like our point is going to be 0, 3. Again, no calculus. All you do is you take your number, plug it into the function. So now what we need to do is we need to find the slope, but the slope is the derivative, you know? So in this case, we're going to take the derivative first. E to the x is still the best function in the world because you just rewrite it. It's going to be 3 e to the x. What's the derivative of sine of x? That's memorized. The derivative of sine of x is cosine x. So it's going to be plus 2 cosine x. Then I need to find the derivative at a specific number because that's where it's touching. Tangere from Latin means to touch, I believe. So in this case, we're plugging in f prime of 0. What's f prime of 0? E to the 0 is still 1 because anything to the 0 is 1. So it looks like we have 3 plus 2. And what is cosine of 0? Well, cosine of 0 is the x-coordinate of my little unit circle picture. It's sort of gotten cluttered, but that's going to be, the x-coordinate is just 1, so it's just plus 2 times 1. So in the end, you get 5. Because e to the 0 is 1 times 3 is 3. Cosine of 0 is also 1. 1 times 2 is 2. So now that we have this information, we are actually good to go. Remember that you can write all of your equation of your any line in point slope form and just be done. I'm going to do that. If you have a point x1 comma y1, then point slope form will be y minus y1 equals n, the slope, times x minus x1. You just, the slope formula where you bring over the x minus x1 so you don't have any fractions. So we are actually done. Let's write it in this case. You're going to take your y, you're going to subtract your y coordinate. That's 3, that's what we found, because we need point and slope, where slope is derivative. Then we write our slope, which is the derivative, 5. And then finally, x minus the x coordinate, x minus 0. So equation of the tangent line questions, they do involve derivatives, but they're not too bad. They're not too crazy. What you do is you want to identify point and slope. To identify the point, you plug in the x coordinate to find the y coordinate. Try to do unit circle stuff correctly. Then for the slope, you take the derivative. Once you take the derivative, you plug in that x coordinate again to find the slope, and then you write it in point and slope form. So let's practice again. Let's do a question a little bit harder. So I'm going to erase this. We're going to erase this. Let's keep it somewhat simple, but somewhat not simple, if that makes sense. Let's change this number to pi over 4. And let's try to find the equation of a new function, the equation of the tangent line to a new function. Let's try to do tangent x minus x squared. So nothing too crazy. So again, anytime you see the words equation of the tangent line, point and slope where slope is derivative. Point and slope where slope is derivative. Point and slope where slope is derivative. So in this case, what we're going to do is we're going to do the calculus later. We want to draw out tangent of pi over 4. But remember, pi over 4 deals with the angle 45 degrees, which is not too bad because the legs are the same of this right triangle. So I think we're good to go. Let's try to find the point first. So for the point, it's going to be x. And then we're going to plug in pi over 4. So it's going to be pi over 4, tangent of pi over 4. Sorry, I forgot the tangent, that's key. Minus this thing right here, so minus pi over 4 squared. So it's going to be a little bit complicated, but we don't have to simplify it all. So this is going to be the point. So it looks like it's going to be pi over 4. What's the tangent? Well, the tangent on the unit circle is, of course, the opposite over the adjacent when you have hypotenuse 1. Notice that the legs are the same because we are doing a 45, 45, 90, so it's just 1. And then what's pi over 4 squared? Well, when you have a fraction squared, you just square both parts of the numerator and the denominator. So this is going to be pi squared over 16. So that's going to be my point. A little bit complicated, but nothing too unwieldy that we can't finish the question. So that's just the point. Now it's time for calculus. It's going to be okay. Why do we need calculus? Because the slope of the tangent line is the derivative. So what's the derivative here? Well, the derivative of tangent x, memorized, is secant squared x. And then finally, what's the derivative of minus x squared? That's the power rule. It's going to be minus 2x. So now what we need to do is we need to plug in pi over 4, and we should be good to go. Unfortunately, pi over 4, when we plug in pi over 4, it's going to be a little bit complicated because we do need to find secant squared of pi over 4. But let me try to rewrite this. The last part won't be bad. It's just the secant squared of pi over 4. So let me just rewrite this. Let me do a little bit of math on the side for you here to try to evaluate this. So whenever I'm doing secant squared, this is the same thing, of course, as secant of pi over 4, all of that squared. Remember that it's nice to remember your reciprocal properties. What is secant related to? Well, it's 1 over cosine. So I can write this as 1 over cosine pi over 4 squared. What's cosine of pi over 4? Well, it's this triangle right here. It's going to be the adjacent, the x-coordinate, which is root 2 over 2. So it's going to be, I'm going to run out of space, so I'm going to go back to the top here. 1 over root 2 over 2 squared. How do you deal with fractions? With squaring, again, you just square the numerator and the denominator. So this is going to be 1 over 2 over 4. And then finally, what is 1 over 2 over 4? Well, you actually just flip that fraction, so it's going to be 4 over 2. All of this was just the magical number 2. So secant squared of pi over 4, all of that work just to get the number 2. So this answer will be 2 minus pi over 2. Because again, if you have two things and you divide it into 4, that's of course dividing it into 2. So this was quite complicated. Our point is really complicated. Our slope is really complicated. But we are done. Let's try to write this in point slope form in this nice little box that I have right here. Y minus the y coordinate. Even if it's crazy, I'm just going to write y minus the y coordinate equals slope, which is this guy right here, because it's the derivative. So it's 2 minus pi over 2 slope. And it looks like we're going to be able to fit everything within this box because you end it with x minus pi over 4. X minus the x coordinate. I spoke too soon. How bold of me. Sort of jinxed myself. So that's the answer here. So again, right, you do the same things over and over and over again throughout calculus. Right when you see tangent line, you need a point and a slope, where slope is the derivative. For point, you just plug in pi over 4, find that point, the y coordinate of the point. Then for slope, take the derivative of the function, plug in your x coordinate. Unfortunately, we had to do a lot of unit circle on the side, but we got there in the end. Once we had the slope, it's just y minus the y coordinate equals slope times x minus the x coordinate. So let's try to do one more of these with inverse tan, and then one more question after that, and we should be good to go with all these inverse and trig stuff. We should be trig masters by now. We are not scared of trigonometry, even if it's scary. So in this case, new function. Let's do, erase this guy. Let's try to do, I'm not sure, what should we do? Let's do 3x minus 4 tan to the negative 1x. So nothing too crazy. Let's just practice some inverse trig. Keep in mind that we will need to know inverse tan of 0 eventually. Let's actually write the process out and let's do the inverse trig as it occurs. So still the same thing. Tangent line, you need a point and a slope, where slope is the derivative. Just keep saying that over and over and over again. So for the point, it looks like my x coordinate is going to be 0. And I do need to plug this into the function. 3 times 0, I'm pretty sure I can do. The part is inverse tan of 0. Whenever you're thinking about inverses, remember you're thinking about sort of the reverse. Whose tangent, what angle's tangent gives me 0? That's actually the point we dealt with earlier. That's the angle 0, because tangent is the y coordinate over the x coordinate. So in that one, it's 0, 1. 0, 1, of course, is 0. So all of this is to say is that the inverse tan of 0 is just 0. So here we're going to have 0, 0. Looks like our point is going to be the origin. 0 minus 0. I'm not going to complain about the origin. So now it's just the derivative. Why are we taking the derivative? Of course, it's the derivative, the slope of the tangent line. How lovely. So what is this slope? It is going to be the derivative. Let's take the derivative. This is going to be a pretty easy derivative. The derivative of 3x, and a constant times x is that constant. So it's going to be 3. What's the derivative of inverse tangent? That's a memorize. I have a constant, so I'm going to rewrite that constant first, and then multiply by the derivative of inverse tangent. That's the one that doesn't have square roots or negatives. So it's going to be 1 over 1 plus x squared. Now I need to plug in the 0, but it's a lot easier because there's no more trig, because we took the derivative of inverse tan. So in this case, we're going to plug in 0. Notice we can just write it out. 1 over 1 plus 0. 1 plus 0 is 1, 1 over 1 is 1, 3 minus 4 is negative 1. So it looks like we have a pretty easy line here. It's going to be y minus the y-coordinate, 0 equals the slope, negative 1, but I'm just going to write negative because I'm feeling a little bit frisky, and then it's going to be x minus the x-coordinate. So that's our equation of the tangent line questions. Again, same thing every single time. Point and slope, where slope is derivative. To find the point, plug in the x-coordinate. To find the slope, take the derivative, plug in the x-coordinate, take the derivative as needed. So one last question. It's sort of a little bit of a brain teaser, just to see if we understand this sort of stuff. So remember that when we take derivatives, we can of course take multiple derivatives. So what is the second derivative? Well, that's just the derivative of the derivative. What's the third derivative? I can't say that word 5 times fast, but what's the third derivative? Well, that's the derivative of the derivative of the derivative. So what we're going to do is we're going to start off with a function. Let's start off with 5 times sine x. And what we want to think about is not what the second derivative or the third derivative is or the first derivative. We want to know what the 101st derivative is. How crazy, how crazy. So this is when usually we denote derivatives with prime marks. F prime of x is the first derivative, F double prime of x is the second derivative. But because we don't want to list out 101 prime marks, once we get to a certainly big number, this means the 101st derivative of this function. So we have an option. The option A is not the greatest option, but you take this function and you take the derivative, and then you take the derivative of that thing, you take the derivative of that thing, and you repeat this 101 times. So as you can tell, that's slightly annoying. So what we're going to do is we're trying to learn tricks. First off, let's try to list a few derivatives, and we're going to gain a pattern. So what's f prime of x? Well, we have a constant here, but it's just that constant times the derivative of sine of x. So it's cosine x. Then what's the second derivative? Well, the second derivative will be, you still write the same constant. The derivative of cosine is minus sine, but I'm going to put the minus in the front. I'm going to keep going with derivatives. Probably not going to go up to 101, but let's just take a few more. So the third derivative here, well, the derivative of minus 5x sine x, you're going to write this constant, so it's minus 5. And then what's the derivative of sine? Well, it's cosine. And then finally, what's the fourth derivative? We'll write it like this so that we don't have to have more tick marks. Well, the fourth derivative is going to be just this constant times the derivative of cosine. Co has the prefix co, so its derivative is negative. The negatives will cancel, so I can erase this negative. It'll be 5 sine of x. So these are the first 4 derivatives. But notice, if you're being a little bit careful, that this fourth derivative actually is the original thing that we started off with. So it looks like we are going in circles and circles and circles and circles. So this is the original function, first derivative, second derivative, third derivative, fourth derivative. But if you want to take the next derivative, the fifth derivative will be the derivative of this, but this is the original, so it's going to be the same thing as the first derivative. So it's going to be first derivative, second derivative, third derivative, fourth derivative. Try to say that word like 50 times fast. It's really hard. First derivative, second derivative, third derivative, fourth derivative. Then the fifth derivative is the same thing as the first. The sixth would be the same thing as the second. Seventh would be the same thing as the third. Eighth would be the same thing as the fourth, and so on. First, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12, 13, 14, 15, 16. So for example, the 16th derivative would be the same as this guy right here. So the original question was the 101st derivative. So what is that? Notice that it repeats every cycle of 4, sort of like with complex numbers and powers of I squared, I cubed, I to the 4th. By the time you hit I to the 5th, you're back at I. Same thing here. What is the 101st derivative? The key is to notice that it repeats every 4, which means that multiples of 4, so for example, the fourth derivative will be the original. What's the closest multiple of 4 to 101? That's 100. So what is the 101 derivative? Which of these 4s, guys, is it? It's going to be this thing right here. It's going to be 5 times cosine x. Because what it's going to be is the 97th derivative, the 98th derivative, the 99th derivative, the 100th derivative hits the fourth derivative. And then when you take that next derivative, 101st derivative, it'll be this one right here. So hopefully that makes sense. Not the most important question in the world, just a little bit of a brain teaser, sort of seeing how a nice pattern emerges as you take derivatives of trig functions. The more important thing of this video was, of course, just memorize the list of derivatives that we introduced in the beginning of the video. Then we talked about tangent lines, where the slope and the point, for the tangent line, what you need is a point and a slope, where the slope is the derivative. I've said that too many times that it sort of wandered out of my brain. If you want more practice with this, whether that be just taking derivatives and just starting listing out the derivatives over and over and over again, or practicing equation of tangent line questions, or even one of these, then check out our video in the link below if you want more practice. It's another Girls Teach Calculus video where one of my former students slowly goes through these questions, probably explaining things better than I do, so check that out. Our next video is very, very exciting because we're finally doing the product rule and the quotient rule, where instead of taking derivatives or just sums and differences, we employ the most famous rules at all. So please be on the lookout for that as well. Hopefully I'll see you then. Like and subscribe if this video was useful for you, and I hope to see you next time. Thanks again for watching, just like normal.